Hello, and welcome to this overview of the Prophecy Shop Floor Data Collection System. My name is Greg Keating, and I'll be guiding you through our tour of the Prophecy application. But first, let's start with a short presentation. First, what is Prophecy? Prophecy is a software application that converts the factory into a smart factory, creating what we refer to as a connected worker platform. Now you'll notice in this illustration, we have this gold cable that's circling through the factory. You'll notice that it's connected to machines here, so we can collect data directly from machines. And as we follow over here, we're connected to this operator who happens to have a tablet. Or maybe we're connected to a device like a scale or a compressor or something of that nature. Needless to say, we're connecting the factory environment and collecting that information and feeding it back to in a consumable format. Now, what are the benefits of this connected worker platform? Well, first, we want to engage quickly. We want to reduce response times in identifying and correcting anomalies. Minutes matter. And if there's a problem on the factory floor, we need to know now so we can take the appropriate corrective action. We want simple and fast displays. We want a rapid operator interaction. We want the operator focusing on their process and not on their data entry work. We want speed and productivity, so we want to automate the ERP transactions and have the inventory as close to real time as possible. And lastly, and probably most importantly, is we want to facilitate continuous improvement in your organization. We want to be that spotlight that shines on the problem in the factory and allow you to take the appropriate corrective action. And again, like I said, minutes do matter. So the sooner we can identify those problems and have you fix them, the more productive your organization is going to be. Now, the smart factory is broken out into two categories: equipment automation, where we're connected directly to the machine, or worker automation, where we are relying on the operator interaction to provide us with the information required. First, let's start out with equipment automation. And where does Prophecy sit in this scenario? Prophecy sitting right here in between the ERP application and your machine and sensors. So we're collecting data and collecting information from the machines and passing it into the ERP. We're also collecting ERP data and processing that to establish the standards, like what is the expected rate or the time allotted to this particular operation. We also have the ability to populate any big data scenario you may have. In Infor speak, it would refer to as the data lake, so that we can populate it and leverage potential AI and machine learning tools to look at patterns in machine outputs. I'll tell you straight out, the ERP software doesn't care about the temperature of your molding machine or the pressure or tonnage in your stamping press, but you as a manufacturer certainly do, and we are collecting that data, and we can leverage that data over a further analysis. We also have what we refer to as a rate of change detection capability, where if the machine control limits are the red lines and you're running right along here at a little bit over 400, whatever, let's say tons. So you're running just a little bit over 400 tons, and then you have this sudden drop for a few cycles, and then it comes right back up again. Well, the machine never stopped because you stayed within the control limits, but you had a significant shift in this particular output. It stayed that way for a short period of time and then came right back. Chances are these parts, I don't know, I can't say that they're going to be defective or non-conforming, but they're certainly suspect, and you want to maybe take a better look at them. Well, this is the type of information we can provide where we can alert the operator that, these 4 or 5 pieces that were produced in this time period maybe need an enhanced inspection. Now let's talk about the worker automation, or the disconnected worker. This would be for hand assembly operations and things where there isn't really a controller to connect to the machine. Now this is an example of our interface here, and we'll take a deeper look in this when we get to the live software. But the takeaway here is the bottom bullet point here on the unlimited users. we don't care how many users you have out on the factory floor. We want as many stations out there as possible, because that's going to increase your ROI, and it's going to bring that realizing value that much faster. The more the software is deployed, the more andon screens that you have out on the factory floor, the more interfaces you have out on the factory floor, is going to allow you to realize that value even faster. There's something called a Hawthorne effect of just by reporting on something and tracking something, you get a 10 to 15% improvement in that process just by reporting and tracking it. Well, that's also coming into play here when we start putting screens and andon boards out on the factory floor showing real-time performance. That cell or that work area is going to get a productivity improvement just by the fact of publicizing the fact that you're tracking the numbers. We have a supervisor interface. In the supervisor interface, we can manage employees, we can build time or build teams. We can show real-time status on where are my employees, what are they working on, how long have they been there, are they achieving their rates. We can also do some light error correction. If an employee makes a mistake, you can go in and make the adjusting entry right from the Prophecy application without having to go through the ERP application. We have a full editor that we can build our interfaces, KPIs, and dashboards with. This is an example of the Design Studio. It is drag and drop. So if you want to add a new element or move things around on the screen, maybe add a new machine output or collect a new piece of data from the operator, it's just as simple as dragging and dropping that element on and binding it to the appropriate tag or property behind the scenes. Our screens are broken out into 3 categories. We have operator engagement screens, where that's where the operator is directly interacting with the software. It's collecting data. You can type in data. You can type in comments or notes. You can view documents, things like that. Then we have the live andon screens, which are showing real-time status of the factory floor and what's happening right now. And then lastly, we have a whole suite of analytics where we can generate dashboards to monitor and measure the performance of the manufacturing environment. How's my factory doing, today, this week, this month, this year, and very graphical. Now, the analytics are more intended for the back office, plant manager, supervisor, VP of ops type roles. So the operators really aren't interacting unless you choose to. The operators typically don't interact with the analytics. You're simplifying the operator experience by just having them focus on their machine-specific interface that's appropriate for them. We have an entire suite of key performance indicators or KPIs. This list is not all inclusive. This is just some of the most common ones that are deployed in virtually every installation. Employee time. I paid an operator for 8 hours. How many hours did they actually work on jobs? And then the next one, the efficiency. When they were running, were they achieving rates? Or the indirect codes, what were they doing when they weren't working on a job? And then the same down in the machine, my machine utilization, what's my runtime versus available time? Did I hit rate? How many parts did the machine produce? What are my downtime reasons, my alarms, and so forth? So again, this list is not all-encompassing. It's just a sampling of the number of KPIs that we have available. What's new in this latest version? Let's shift over to the live software. So I'm already logged into the application, and we can see here that this is a roof-off view of our factory, what we call the virtual factory. So we're on top of the factory, and we're looking straight down with the roof off, and modifying this layout is simple with using our editor tool to drag and drop. So you can just move things around and have the mimic your plant layout. You can draw your walls and your aisles very easily. Now, what's important about this is it's showing the real-time status. So there's about 30 machines on this screen here, and I can see that my factory's doing okay. I would say probably 3/4 of them, maybe even more, are running right now. I have a couple that are down. which are grabbing my attention. They're blinking red. So if my office was right down here and I was going to hit the floor, my first stop is going to be right to I-25 because it's down, and I can find out what's going on there, and then come over to CO1 next and find out what's happening and what the status is of CO1. There's a couple of machines here. The blue is where the operator's calling for help. They're asking the supervisor to come over to help them with something. I have a couple machines in setup, a couple machines that are offline right now. So it's just a very simple, very graphic display. Envision this being on a TV screen in your break room or in your conference room or in the hallway of the office, or even out on the factory floor itself in the production office. So it's very simple, very easy to interpret. Now I can drill into particular machine here to get the status of what's happening in that machine. So I've drilled into the IO1 machine, and in a moment here we're simulating collecting data from the controller itself. So this is a Haas CNC mill. It's currently running. It's been running for about an hour and 40 minutes, hour and 45 minutes. It's currently running this job number DJ385. Suffix 0 is this gear 12T part number, and we're making 500 units. Now, this information we pulled from the machine on what program is it running, what's the tool ID, the dwell time, any override dials that may have been set on the machine. The center box here is the runtime versus downtime. It's the last 24 hours represented in minutes. So we've run for 625 minutes. It's about half of the time. And then we have a variety of different downtime reasons for broken tooling and equipment failure and so forth in this chart. In the top right, we have the productivity stats. So we've completed 10 pieces. We've rejected 2, so we have an 80% yield. Our productivity is running at 84.7%, our utilization at 72%. We take those 3 percentages, multiply them together, and we calculate our OEE for the last 24-hour period at 78.9%. Not great, but not bad. It's okay. Call it 79%. So it's okay. Then down here on the bottom, we're reading the alarm status from the machine. So the spindle speed, spindle load, coolant pressure. Clearly, we can change these alarms based on the type of machine that we're viewing here. And then lastly, because we're integrated to the ERP, we can pull in the maintenance requirements. So this is the preventive maintenance schedule. And in here, we have to replace the coolant tank filters every 500 run hours. Well, we know how many hours the machine is run. We're currently at 400 hours. So we know we have about 100 hours or about 4 days left until we have to replace that coolant, that coolant tank filter. So we better make sure we have one on order and have that in line, or maybe have created the work order to replace that coolant filter, which has therefore updated the production schedule. Now we also have departmental level screens. In this example, picture a TV screen mounted to the wall or mounted to an I-beam out on the factory floor. And this is my CNC department. And in my CNC department, I have 8 machines. And I can tell very simply that right now I have 3 of them that are green. Green is good. And here's my Haas CNC machine, and I can see the productivity utilization and OEE for the current day. And in here, let's say this one is interesting. Haas CNC machine number 3, its runtime has been exceeded by 3 hours and 26 minutes. So we allocated X number of hours to complete that job, and we're call it 3.5 hours over that allotted time. Now, right now, real time, I can make a decision. Do I want to stay late tonight and work overtime to make up this 3.5 hours, or maybe work the weekend to make up that time, or do I take the hit? And now everything behind it is now pushed back by 3.5 hours. So again, I can make that decision real time. I don't have to wait till tomorrow to find out I didn't do so well today. This one's also interesting here. The Haas CNC machine number 8's waiting on material. So the machine's sitting idle now, waiting for the material handler to bring materials over, and it's almost an hour. So now, again, I can get on the walkie-talkie or get on the phone or go and find the material handler and find out what's going on, because I have the machine down for almost an hour now waiting for product to be delivered. So again, just pushing productivity and making sure that we're achieving our targets and our goals. Now, perhaps we we don't want to see it that way. Maybe I had the way my building is laid out. I want to look at things a little bit differently. So I'm going to open up the multi-department status screen here. And here are my CNC machines. Now, this doesn't mimic a plant layout. This is just looking at my functional departments. And here are my CNC machines with what's happening in those machines, and my robots, and which robots are running, which ones are stopped, which ones are in setup, or my press brakes and lasers. And I can maybe click on one of them and bring in specific values, specific readings from each one of those machines, or maybe even maybe I'm pulling in the compressor condition. What's my current air pressure and temperature of the compressor or the chiller or something like that. So it doesn't have to be just factory machine, production machines. You can pull in data from other assets as well in your factory floor. Now let's look at a couple of dashboards. Let's start out with this dashboard, which is looking at our OEE, our overall equipment effectiveness. This one is filtered to pull in a quarter's worth of data, and right now my filters are wide open, so I'm pulling in the entire factory. And looking at this, my availability, my utilization was at 98.23%. Coming over here to my quality was at 99.68%, almost perfect. But my performance, my efficiency really took a hit at 10.39%, which pulled my overall OEE down to 10.18% over that period. That's not good. So clearly I have an efficiency problem. The machines are running and I'm making mostly good parts. So we need to really focus in on our efficiency. Now I can drill in by specific work centers or machines, tools, items, whatever I need to filter on. Maybe I want to filter by shift and look at just my first shift performance. And when I repaint this to do just first shift, my utilization, my availability is almost 100%. It's 99.94%. My quality dipped a little bit down to 98.8, but my efficiency fell even further. So clearly I have a productivity problem, either some bad standard rates or some operators that are underperforming on my first shift here, because my performance fell down to 3.18%. So let's look at some other ones, maybe something a little bit simpler. Completed versus scrap. This is a pretty simple chart here on how many pieces did I produce, how many pieces did I throw away. So I made 105 and I scrapped 10 of them on 9/6. And on this one, I made 80 and didn't scrap any. And the same thing on 9/8. Made 100 and didn't scrap any. So again, very simple displays. And now let's look at, not all of them have to be graphical, all of our dashboards. Here's one that's more in a report form. We're looking at David Danielson's direct labor. And David, he worked for 8 hours. And here's the times that he spent on jobs. So I have a goal for David or all my operators, that they have to spend at least 80% of their time on jobs. And in this first day here, 9/6, David only worked 5.5 hours on jobs. So we ended up with a 68.8% working on jobs. The rest of the days he exceeded his goal at 84.4%. Now, so something happened on this day on 9/6. And again, I'm not going to lose a lot of sleep over it, because his overall percentage for that week period, he worked 56 hours, or got paid for 56, worked on jobs for 46. So he had 82.1%. He was still over his goal. Just that one day we had a little bit of a slip up. Now we can also look at a scrap analysis and pull data in from various areas of the system and put it on one screen and make it easy to consume. So here are my top scrap items. The FA10,000, scrap 15 of them, the 30,058, scrap 9, and so forth. So I can see which parts are generating the most scrap over here in this top right, what are my top scrap reasons. And then down at the bottom, the top scrap work centers. So I bet seeing that they're both 15, I could drill into the data and find out for sure, but seeing that they're both 15 and 15, I would say if I can solve my scrap coming out of the assembly area for this FA10,000, I can cut my overall scrap down and reshape the landscape of my Pareto chart here just by doing a Kaizen event to target the FA10,000 assembly process. Simple. I mean, it's simple to identify. And now let's go out and let's attack the problem and drive our scrap numbers down. So now let's talk about the operator interfaces and what the operator experience would be like. So I'm going to show a couple of different variations of this. First, we're going to start out with a molding machine. This is an injection molding machine interface. And again, I'm looking at this from the perspective of the operator. And in the top left corner is my job information that I pulled directly from the ERP. So I can use this drop down and get the listing of the jobs that are in that schedule there. I'm currently set up, or I'm currently planning on running this part number 12393. It's for part number 004669-79J. The job is cut for 1,000. I've made 53 of them so far, so I still have 947 to go. This center box is reading the state of the machine. So the machine is currently at an idle state. We read in the batch and we haven't started producing parts yet, but we're at 0 of the 947 piece balance. On the top right are my OEE stats, or my productivity. So the machine's been idle for quite a while. I can see my setup, my running, my quality time, and so forth. These buttons here are for the operator to interact with, which we'll see in a moment. I can record my scrap and give it a scrap reason here. The bottom two boxes are reading data in from the machine. So what's my injection pressure on my injection molding machine? What's my barrel and mold temperatures? And then over here I have clamping force, injection pressure, hold pressure, and so forth, and just monitoring the machine outputs. So let's go ahead and make some parts. So I'm going to make some parts by starting the setup. And I'm going to simulate doing the setup here. Now the machine state has changed to setup. And we're going to go ahead and stop the setup, and we're going to go ahead and start running. So I'm going to hit the start run button, and we're going to see up here in this machine state is going to give us the status of what's happening. So this injection molding machine is now closing and it's clamping up, and we're going to see it change to injecting here in a moment. When it changes to injecting, we're going to see our injection pressure come up. So now we're injecting plastic. And here's our injection pressure. And now it's done injecting pressure, or plastic, excuse me. And now it's cooling and homing the machine. And now we're going to clamp again, and we just made a part. And now we're going to inject. We're going to see the injection pressure come up, and then it's going to hold, cool, and then we'll home the machine, and we'll see that our quantity produced will change to a 2. So I'm going to go ahead and end the run now that we've produced 2 of our 947 pieces. I'm going to hit the end run button and stop. And I get this action completed successfully. And now the machine is back to its idle state. And I'm connected to Cloud Suite Industrial. And here are the unposted job transactions. And I've already filtered for today's date. So I'm just going to hit the refresh button here. And here are the 2 pieces that I just produced of that 00466979J item. I produced 2 pieces, and here's my unposted job transaction. Now, in Cloud Suite Industrial, I could have had this auto post, but it's just easier to show the speed in which those transactions are appearing and updating in the system. So now let's change from the injection molding plastic machine, and let's look at a different kind of interface. This is more of a continuous feed system, or continuous feed machine. It's a gluing machine. And here's my job queue. And this job queue has a little bit more information in there. We're giving the job number, the suffix, the operation number, but we're also pulling in the start and end time from the scheduling engine within the ERP system on exactly what day and time this is supposed to start, what the item, the revision, and how many pieces we should be producing in this operation. Now we do have, here's some job information in here. I'm currently set for this KS001 blank item. It's job number DJ12808, suffix 0 op 10. I can put in quantities in here and submit that. I'm also pulling in some machine information, roller pressure and temperature from the gluing machine, how many pieces I have available to produce, and I haven't produced any yet, and then any accumulated times for setup and running and downtime. Now, I'm also in this machine, I can perform inspections. So I have this quality testing button, and I'm currently flagged for this KS001 blank part number. I'm going to hit the quality testing button. And this is our quality interface where we're reading in the control plan from the from Cloud Suite Industrial. And now I have to tell it how many parts do I want to inspect, or what's my sample size. I'm just going to put in, I'm going to check one piece. So I'm going to put a 1 in there and hit the create tests. And we're going to read in the control plan. And here are the 4 things that I need to inspect on that part: the hole diameter, the profile, the flatness, and then a visual check for no heavy marks or scratches. Now, when I click on the hole diameter, I can say, what gauge am I using? And I can identify the specific gauge that I'm using for this particular inspection, as well as entering the value or collecting that value. If I have a gauge port or something like that on the gauge, I can measure the part and hit the foot pedal and pull that data right into the value and record the result. Now, also, I can generate some SPC data. So when I hit the control chart button, we are now going to pull in the inspection history for this one characteristic on this item. We're going to pull in the last 25 pieces that were inspected and calculate some SPC statistics on them. So here are the last 25 parts. Here my red lines are my limits. So this is 0.012 to 0.014 is my spec limit, my lower control limit and upper control limit. And here's my actual inspection history. So I'm pretty good in the last few parts here that I've measured, that I'm pretty close to nominal. I can use the crosshairs to see the exact value. So, this one was at 0.1315 that was measured on 9.9, and my low point here was at 0.1231. So overall, my CP is 1.5, my CPK is 1.52, PP is running at 1.6, and my PPK is running at 1.55. So again, very simple operator-based SPC capabilities for them to see the control chart. And we'll close out of that, and we'll close out of this. And now we'll shift over to a different operator interface. This operator interface is a totally disconnected machine. It's an assembly station. And the same thing, David Daniels has been clocked in on this job. Here's my job queue, all the jobs that are listed in there, the job suffix operation, what item, again, the start date and time for this particular operation, and how many pieces we have received in that operation. So that's either, if this is the originating operation, it's going to be what the job is cut for. If it's a secondary operation, it's going to be how many parts did the operation in front of it already produce that are available for me to process in this particular operation. Now, this one also has the bill of material information in here. So this job number DJ11854 suffix 3, operation 10, this is the BOM for that particular operation. I can see what's required, how many have I already issued, and I can come in here and I can issue material directly from this interface by coming here and clicking on, let's say, this item, and then I can select it and then go ahead and issue it. And that's going to open up this diagram where I can perform material transactions. I can issue the raw material out to the job right from this interface. Pretty simple, straightforward, and streamlined process. So I need 50 of them. I've issued one so far. I have 49 to go. I can say which location those parts are in. And then from there, I can put in how many parts that I'm going to issue. So in the location stock, there's 4 of them available. Maybe I'm going to issue all 4, and I can go ahead and process that transaction. Now, this one also has the quality interface like I showed you before, and we can open up documents that are associated with this particular item. So this job number DJ11854 maybe has a couple of documents associated with it. Looks like it's only one. When I bring this drop down, if there was multiple documents associated with this, I would see each document listed. But I'm going to go ahead and open up the cable carrier here and hit the open button, and here I can see the drawing for this particular part. So I can serve up whatever documents that are associated with this part number in the document control system and serve them up to the operator as well. Now this machine, because I don't have any direct connection to a machine, I have a series of buttons over here. that these buttons can be used to update that roof off view. So from this interface, if I need supervisor help, I can hit the call supervisor. If I need maintenance or a material handler, or I can tell the system when it's running, when it's off. Because I have no machine to connect to, I need the operator to tell me when it's running, when it's off, when it's in setup, when it's down, and then we also give the operator the ability to call for assistance if they need it. So we've talked about the operator interfaces. We also have the entire editor program for editing the diagrams and the dashboards. We also have a downtime manager. In the downtime manager, I'm going to pick a couple machines here. Just going to pick 4 of them. And I'm not going to use the current date because I haven't really recorded anything in here. I'll go back to the 8th. Here, I'm going to go ahead and fetch some data. I need to go back a little bit further than that. So let's go back to August 1st and go ahead and fetch the runtime data. And here is a graphical representation of the current state of the machines. So this drill 10 M1, I can see I have some downtime. I have some scheduled maintenance time in there. Looks like I had a power failure on that machine, and then the operator, no operator to run it. So I can see a graphical representation of that machine kind of spread out in a ribbon format of what happened on those particular days. Now, if we look at this drill 10 M2, looks like it's up, down, up, down, up, down, up, down, up, down. It's not running 55% of the time and running 44% of the time. Maybe I want to send the engineer out there, the industrial engineer, because maybe there's something with the fixturing in this part. It's taking the operator too long to get the part in and out, that maybe we can do something to help them and get this to be more green, because right now it's scheduled to run and it has been running, but its productivity isn't that strong. I wish they were all like drill 10 M3 that just ran all day. So it's just solid green one. And then same thing with drill 10 M4, that we have some sporadic downtime events in there, but overall, it ran for 92% of the time and was down for 7%. That's still pretty good. So this machine obviously needs some help and needs more reliable staffing here, but this is the machine that I'd really be targeting on to get the engineers out there to see what we can do to improve the productivity in this process. And we also have what we refer to as the manufacturing hub. And the manufacturing hub is designed for a turnkey solution for a pure disconnected environment. So in the manufacturing hub, I'm going to select which workstation I'm working at, and then I'm going to clock on as an employee. I'm going to come in as employee number 1 here. And these are the basic transactions that I can perform in here. I can start and end a shift, go to and from break, to and from lunch, the basic time and attendance transactions. I can clock on to a standard job, be part of a team job, or a multi-job, which is one operator tending to multiple machines at the same time. I can do movements and setups and machine transactions. I can issue and return raw material, perform just-in-time transactions, or clock on to an indirect code. I'm not working on a job. I'm working for engineering, or I'm working for quality, or whatever the case may be. Now, in this example, I'm going to click on the standard job button here. And David's not assigned to a work center. If I assign David to a work center, it would pre-filter for just the work center that David works at. But I'm seeing the entire queue, the entire factory here. Now I have this search capability over here that I can search for what job. So let's say I don't know the job. I don't even know the part number. I only know a piece of the part number. So I'm going to type in the word blank in here. And when I type in blank, this list filters now for everything that has the word blank somewhere in the part number. And I can maybe now I'm saying, well, I'm going to work over at the 60 ton. So I'm going to keep the blank in the search filter here, and I'm going to drop my work center list down, and I'm going to pick the 60 ton machine. And now my list just changed to these 4 jobs. Well, all right, so I'm going to take the blank off of there. Now let me see the entire schedule for the 60 ton press. So I'm going to hit the X here and clear that. And here's my entire schedule for just the 60 ton press. Now, any one of these columns I can sort by. So if I want to sort by item number, I can just click on the item number, and now they're all sorted by item number, or maybe by quantity. So this one's 100 pieces, this is 1,000, and so forth. Maybe most importantly, I want to sort by due date. So here's the one that's old, the one that I need to run first. It has the oldest due date. So let's get rid of this 5,000 piece job here for this KS01 blank. Which that's a good idea. Let's go ahead and click on that one. And when I click on that that particular job, I get this screen appears, and I can see which operation. I have my little hamburger menu over here, and I can see what my materials list is. So what raw materials do I need? I need this raw material. I need 515 pounds of it. I've issued 100, so I don't have any more. This one is a backflush material. I need 5 of them. And based on my backflushing, I've already issued 1.82, and same with the die here. I need 5,000 of them, and I've backflushed out 1,816 of them so far. Also in that hamburger menu, I have access to document control, just like what we saw in the other diagram. This one, if I need to see the drawing for this particular part. So here's my drawing. So again, we can serve up documents right out of the document control system, right to the operator. So let's go ahead and start the run here. And so now David is now running this job number for the KS01 blank, this DJ12518 job number. I'm going to go ahead and hit the exit button. And I know that I'm running that job because the standard job button when I'm logged in as David Daniels has turned green. So now let's change personas for a moment. And I'm not going to be David Daniels. I'm going to be David's supervisor. So I'm going to come over here to the supervisor interface. And when I first open the supervisor interface, here are my jobs. So I'm running this DJ12518 for the 5,000 pieces. I've made 3,960 of them so far. It should have taken me 2 hours and 16 minutes to produce this. I'm actually at 2 hours and 13 minutes. So you see it's colored in orange saying, hey, you're approaching the allotted time for this particular operation. This other one, Jared Powell, is running this other job for this 80 lens 24. We're making 7 of them. It should have taken him 8 minutes, and we're at 8 days. So clearly, Jared forgot to punch out before he went on PTO. So now I'll bring down my hamburger menu. So where are all my employees? And where are all my employees doing that I supervise? So there's 4 of them. Here's David Daniels. He's been clocked onto that job for 1 minute and 12 seconds. And here's Elizabeth Patton. She started her shift 57 minutes ago. She hasn't clocked on to anything yet. So maybe I need to go find Elizabeth. Maybe Elizabeth forgot to clock onto a job. And here's James Robinson. He clocked on 57 minutes ago, and he's working on an indirect code. James typically gets stolen by engineering, and he does work for them. And then here's Jared for the 8 days. Now, additionally, I can manage employees. What permissions do they have? What types of transactions can they perform? Do they work on specific work centers? I can manage teams. I can build teams. So maybe Elizabeth and David are a team, and they can go off and do certain jobs together. I can send alerts to all the stations out on the factory floor, a fire drill at noon or customer visit today or something like that. I can also look at the transactions. Oh, this is interesting too. You saw that the screen just refreshed. So this screen will auto refresh. I don't have to hit a refresh button. I can just leave this screen up if I'm the supervisor, and it's going to auto refresh every minute or so to show me the current status. But let's look at the transactions here. And the transactions, let me look at my production history. So we're going to look at just our run transactions. And I'm going to go back into August here. So I'm going to look at all my run transactions from August 1st through today. So I'm going to go ahead and view the transactions. And here are all my transactions that took place in that time period. And notice that on the far left, I have this little pencil icon here. So I'm going to pick on this operation that took place on 9/4. And I'm going to go ahead and actually, I'm going to pick the one right above it. I'm going to hit the pencil here. And anything that's in white, I can update. So maybe, David here on this transaction, maybe forgot to punch out and I need to fix his end time, or he forgot to punch in or something like that. So I can fix anything that's in white, I can fix. So I can fix the times, I can fix quantities. Maybe it wasn't 200, it was actually 2,000 that he produced. Or in this case, David had some scrap. So I'm going to put some scrap in here where there wasn't any before. So I'm going to put in one piece and I'm going to give it a scrap reason. I'm going to say that it was equipment issue. So, and I can put some notes in there, part got stuck. So I can put some notes in there of what happened. I can do a total reversal of the transaction. I'm not going to do that. I'm adding this one piece of scrap, and I'm going to go ahead and hit the save button here. And now it is processing that transaction back into Cloud Suite Industrial. So now let's come back to being David again. And we'll go ahead and select the Stamping Work Center. And we'll come back in as David Daniels. And here's David's green box. So we're going to go ahead and clock him out. He worked a couple minutes on that particular job. We're going to go ahead and end the run. And when I end the run here, I'm going to say that David made 300 pieces in that period of time that we were working on that, and we didn't scrap any. So I can also check the operation is complete. If we're done manufacturing that, I can check that box. Or maybe we didn't produce any quantities and I just wanted time on there. So I'm going to go ahead and hit the save button. And then I get this message to appear saying, do I want to make the labels for the 300 pieces that I just produced? And I can check this box and it will make the appropriate labels. And I'll go ahead and say that I'm going to make it, I don't have a label maker attached, so I'm just going to call it Greg. And now I return to my job queue. I can clock on to my next job. I'm going to go ahead and hit the exit button here. And now let's come back into Cloud Suite Industrial. And I'm going to hit the refresh button. And I have 2 more transactions in there. The first one is the 300 pieces that David just produced, and it took us 0.08 hours to produce that. So here are the 300 pieces. And then I have this other transaction for the same job, and that is the 1 piece of scrap that I had that equipment issue associated with that. So again, full rapid interaction or integration into the ERP system, in this case, Cloud Suite Industrial, and it's very simple to do, and we're making our shop floor data collection as close to real time as possible. That concludes today's presentation of the Prophecy shop floor data collection system. If you have any questions, feel free to reach out. We're here to help you and support you, and have a wonderful day.